do the solution in resolution in predicate logic. So first we'll see different rules. So here it is bit different than your forward and the backward. So in the forward chaining and backward chaining, we have first order logic, and we'll take the first order logic as it is. We may do some simplification on first order logic, and then we try to solve it with the forward chaining and backward chaining. Now here we have some sort of rules that we have to see. Now the rule is, the first rule says that convert given facts into first order logic. So whatever facts you have been given, you have to convert those facts into first order logic. So first order logic, we know what is first order logic is, what does predicate logic is. So in that we just change the facts, like we have changed the fact in the morning classes. Then what we do is we'll convert the first order logic into CNF, which is called conjective normal form. So this conjective normal form is more simplified form of first order logic. So in that conjective normal form, we have to change. So whatever facts we put into first order logic, those facts we just convert into conjective normal form. Now after doing that, the next is negate the statement to be proved. Now after that, what we'll do is, whenever we find out first order logic and we just convert into this conjective normal form, we just negate it. All the statement will just negate it. And after that, we'll draw the resolution map or the graph to solve the problem or to prove the facts or the proof anything. So let's see the example that we have seen in the morning classes. So the example is this. The law says that it is a crime for an America to sell weapons to hostile nation. So what first sentence says that? First sentence says that in America there is a crime if someone of American company is selling the weapon to the hostile nation. So it is a crime. The second sentence, it says that the country no, an enemy of America, has some missiles. So there is a country called no, which is an enemy of America and has some missiles. And all of its missiles were sold it to by Colin West. So there is a company called Colin West who sell all the missile to the nation called no, and this no is the enemy of the America. And this Colin West is also American. So what we have to prove? We have to prove that this Colin West is a criminal. So that we have to prove. Now here if you'll see that whatever facts we have to convert into first order logic. So we have just converted this fact into first order logic. So this is written in first order logic, which is your predicate logic. So it is a first order logic statement that has been given, but we haven't changed this first order logic to conjective normal form, right? So now we'll see that how we can do the conversion of this particular statement, this particular facts, to first order logic. Now in the first order logic, we define some clauses, and these are some sentences. So we have 7 sentences that will come up. The first sentence, so all these sentences we have seen in the morning class also. So what is that? America X means X is some company which is an American company. Y is a weapon. X, which is American company, selling Y, which is a weapon, to the nation Z. Now, the facts that we have just seen in the form of sentences are converted in the form of sentences, right? So that fact is in the form of sentences, and these sentences are first order logic. So about this, we have seen in the morning classes. So the first, it says that X is American, means X is some company which is American. Y is a weapon, sells X comma Y comma Z. It means that X is a company which sell Y, which is a weapon, to Z, and Z is nothing but some hostile nation. So it proved that X is a criminal. So that particular statement, if it is true, it proved that it implies X is a criminal. The second sentence is any variable X which is a missile, and Nono own X, means Nono own this X, and this X is a missile, means Nono own missile. Then what is the conclusion? Conclusion is this West, which is a company, sells X, which is a missile, to Nono. The next sentences is X is an enemy of America. X is what? X is some country which is a enemy of America. So we can say that X is a hostile country. Next is X is a missile. That implies that X is a weapon. So weapon and missile means missile is also a weapon. So we have just converted it. Why we have converted it? Because the first statement says that anyone who is selling the weapon to the hostile nation or the enemy nation is criminal. That's why the weapon has been used here. So whenever this missile will come, we just convert into weapon to prove this, the criminal. Now, for some X means Nono own X, missile X. It means that for some X means the missile. For some missile, Nono owns this particular missile. Now here it says that Colin West is an American, and here the statement is Nono is an enemy of America. So all these are different sentences that will be come out with the example that we have. And what is our goal? The goal is to find out that Colin West is a criminal. That we have to find it out. So here, if you see, these all are first order logic definition, means these are all predicate logic. Now for the example in the resolution, and we have to prove it by resolution. So for that, we have to convert this whole first order logic definitions into, first we have to convert the sentences to first order logic, and then the next step is to convert this first order logic into CNF. And what is CNF? CNF is called conjunctive normal form. So in that we have to change. Now we'll see some rules of converting into conjunctive normal form. So these are some rules. So we'll see one by one all the rules related to convert what we are converting, the first order logic. We are just going to convert into conjunctive normal form. So we are going to see different rules by which we can do that. So the first rule is called eliminate biconditional and implication. We know that what is by implication and implication, or biconditional or implication. So the first is this biconditional. So if we have any statement like this, alpha bi implies beta, or alpha biconditional beta, so we just eliminate this biconditional with this statement. It says that alpha biconditional beta, so we can write it down. Alpha implies beta and beta implies alpha. The second, we can eliminate implication. This is the implication symbol. So let's say if we have alpha implies beta, alpha is one clause, beta is another clause. If one clause implies another clause, so we can just eliminate this implication by this negation of alpha and then or, which is your disjunction beta. So negation of alpha, disjunction beta. In that way, we can convert the implication sign. So the first thing is, whenever we got by implication and implication, we have to convert or we have to eliminate it. This is the first rule. Now come to the second rule. The second rule is move negation inwards. So whenever we got some sentences or we got some clauses with the negation symbol, and that negation symbol is outside the clause, so we have to put inside the clause. So this is one example where there is a universal quantifier. So this is the universal quantifier we have. It says that for all x p, so, and that is all negated. So when we want to put this negation inside it, so we have to convert the universal quantifier to existential quantifier x and then negation p, so that negation will be coming inside. Now if we have this existential quantifier and then we have the negation, so we have to convert, we have to change it. So we'll do the universal quantifier and then negate. So this is how we'll do. Or if we have a simple clause alpha, this is your disjunction beta, and there is a negation, so we can write it like De Morgan's rule. We can put it inside that negation of alpha. This or will be converted to and. It will be is a conjunction. So conjunction has been converted. So negation of alpha, conjunction, negation of beta. Okay. Now we have another way. This is the conjunction we have. So when we want to put this negation inside it, so that conjunction will be changed to disjunction, means this and will be converted to or and the negation will come in between. If we have two negations, it is equal to so we'll eliminate these negations because we have two negations. So minus minus, if we are writing or negation will do. So it is negation alpha is alpha. So this is another rule of converting first order logic to CNF. Next rule is called standardized variable. Now we may get some situations where the number of variable inside the clause is you can say similar, like here, like we have some y, here it is written, and here also it is written some y. So we have used y variable at once. Again we are using y variable. It is putting the ambiguity in the clause. So what we do is, to solve this particular problem, we just replace this y to another variable called z. So here that y has been changed to z. If you can see here, this y has been changed to z. That is called standardized variable. Now come to the fourth rule, which is called Scalamization. We have seen in the forward and the backward chaining also, where to eliminate the existential quantifier, we just replace and the variable into some constant. But sometimes we cannot replace all the variable to the constant. So for that we use Scalam function. We just not use Scalam constant. Instead we use Scalam function. Here we have seen this existential instantation method we have used earlier, in which for eliminating this existential quantifier, we use instead of variable, we'll use some constant. Here, to remove the existential quantifier, instead of variable, we'll use some Scalam function. So that Scalamization we'll use here. Each existential variable is replaced by a Scalam function of the enclosed universally quantified variable. So here we do that. So if we have the universally quantified variable, that in that will change it. So here you can see the universal quantified variable is x. So we'll change this y to function of x. This y to function of x. Here also this y to function of x. So instead of changing to the constant, we'll change the variable to another variable which belongs to the universally or universal quantifier. So I think it is clear. Here f and g are Scalam function. Here this f we have used and here g we have used. Okay. Okay. Next is your drop universal quantifier. Now here what we do is whenever we got universal quantifier, we just drop it. How we can drop it? It is very simple. We doesn't have to do anything. If we have universal quantifier, so that universal quantifier will just eliminate it. And we are not putting anything else. So here it is saying that for all x, x is a person. Here we'll say x is a person. That's all. Now the next is distribute or over and. It means distribute disjunction over conjunction. So if we have these type of clause like alpha and beta or gamma, so that can be represented as alpha or gamma and beta or gamma. So in that way we can just distribute the disjunction over conjunction. So by putting all these rules into the first order definition clauses that we have just find it out, in that we'll apply all the conjunctive normal form methods and we'll get this. So this is, we are converting. So this is my first order logic. When we convert this first order logic to CNF, that is conjunctive normal form, it will look like this. And at last has been negated. Here the goal is negated. Now here the goal is negated. So if you see here, negate the statement to be proved. So only the statement which has to be proved will be negated. Not all other sentences will be negated. Only the proof, that is your goal sentences, will be negated. So this sentence will be negated. All other sentences will be converted into CNF. Now this will be negated. Now after that what we do is we apply the resolution inference rule in finding out and proving this Colin West is a criminal. So to prove Colin West is a criminal, we'll start with two things. We'll start with the first definition. This is first sentence that we have defined, and we'll start with the goal. So these two clauses will take, this is one clause, this is one clause, and this is another clause. We'll take it and we'll start drawing the graph. That is your resolution graph. Started with the goal clause and the first sentence. So this is my first sentence and this is my goal clause. In both we'll apply the resolution. So we'll apply here, we cannot apply a resolution, we'll apply unit resolution, because here we doesn't have any complex clauses. Here it is only one atomic clause. So when we apply here, it is so what we'll get, we just remove this criminal X and the criminal West, because this is negation and this is not the negation one. So we just cancel it out with the unit resolution, and we'll apply the unification. Unification means this X could be converted into West. So after applying the unit resolution and unification, what we get? We get this. So whenever we got X, we just convert into West. And here also this X will be converted into West, and because the criminal has been omitted out by the unit resolution. So this is my clause that we get. Now after that, we use another CNF that is there. So we can use any of the CNS again, and we'll apply this into this statement. So we'll apply the sentence called American West. Now after that, when we'll apply this American West, the resolution, unit resolution with the clauses given. So what will happen? What will be the next clauses that we have? These two will be eliminated, and the rest of the thing will be left it out. So the rest of the thing will be left it out. Again, we'll apply with the sentence negation of missile X or weapon X, that will apply here with this. So with the again resolution rule, so what we get, this weapon and weapon will be cancelled out, and you can see that this because this Y is nothing but okay. So yeah, so the Y is nothing but your Y is nothing but a missile, right? So here the weapon and weapon has been omitted out, and you get here the missile, because the weapon and weapon is not there. Then we'll get missile, and this X will be replaced by Y, and the cell will come as it is, and the hostile will come as it is. After that, we'll again apply the sentence missile M1. Now in this particular case, what will happen when we'll apply the unit resolution and unification? So this missile and missile will be omitted out, and from Y will be converted it to M1. So this Y will be, so whenever we get Y, this Y will be converted into M1, and so this Y is converted into M1, and the hostile Z is not converted, so Z will be coming as it is. Again, we'll apply one more clause with the clause that we have just find it out. And when we do that, so what is left here is, here it is cell West X no, that will be omitted out, and hostile is not there, it is okay. Then here you can see that X will be replaced with M1, right? And this Z will be replaced with no with the unification. So the next will be like this. So this X will be converted into M1, and this Z will be converted into no. Now after that, we'll again apply the sentences that we have. From that sentences, we'll pick up one sentence, and we'll just apply it here, and we'll do the unit resolution. Here quantification, unification is not required, because already M1 is there. This is a constant. So these two will be eliminated, and the rest of the thing will be given again. After that, we'll again put with the sentences that no owns M1. This own and own will be eliminated, and the hostile no will be left. Now hostile no will be left, and again we'll apply the sentence called X is not the enemy of America, and X is hostile. When we'll apply this hostile, and this hostile will be removed by the resolution. This X will be converted into no. So what we'll get? Only negation of enemy no, comma America, that will get here. So negation of enemy no, comma America, that will get. After that, we'll apply another sentence called enemy no America, that is there from the sentences. So this two will be cancelled out with the help of unit resolution, and we'll get null. So once we'll get null, it means that whatever assumptions that we have taken at the very beginning will be true. So whenever we get null at the very bottom, we say that we have proved what we have assumed earlier. So that process is called resolution proof. using resolution. Now we have some examples that you can do. So this is some example where we can use the resolution for proving it. It says that the first example is everyone who kills animal is loved by somebody. Everyone who kills animal is loved by nobody. Raj likes all animal. Either Raj or Ravi killed cat named Kitty. Cat are animals. So what we have to prove? We have to prove that did Ravi kill Kitty? That we have to prove. Second is every boy or girl is a child. Every child gets a doll or a train or a lamp or of coal. No boy gets only doll. No child who is good gets any lamp of coal. Jack is a boy. So what we have to prove? We have to prove like if Jack doesn't get a train, then Jack is not a good boy. That we have to prove. So these two are the examples that we have to use the proof using resolution, and we have to prove it. So first of all, what we have to do? We have to just convert this into first order logic, and then convert into CNF, that is a conjective normal form. And after converting it, you have to use the three things. First is unit resolution. These two are the rules, and the unification by which we can at last, if we'll get null, we so we can prove that Ravi kill Katie, or we can prove that if Jack does not get the train, then Jack is not a good boy. So in that way, we can do the conversions, and we can prove it.